Welcome back, everyone. We're going to do example 3 and 4 in this video. So let's get started. So this question says, what is the amount concentration of aluminum ions and sulfate ions in a 0.40 mole per liter solution of aluminum sulfate? And I should say at this point, we are getting these questions from the Google slideshow that you can find in Genius. So if you don't know where those are yet, please make sure you contact me and I can help you out with that. But make sure you have those in front of you as we go through this video. All right, so we've got some aluminum sulfate, and you see the chemical formula there. And we want to figure out the concentration of aluminum ions and sulfate ions in this mixture, and this can actually be a bit of a difficult concept. So I'm going to walk through this one a little bit more slowly. So let's picture aluminum sulfate. So I've got aluminum sulfate, and what I'm going to do is actually write out the dissociation equation for aluminum sulfate. So when aluminum sulfate dissociates, I'm actually going to write it in the aqueous state because once it dissociates, it's going to turn into aluminum ions with a 3+ charge and sulfate ions, each with a 2- charge. But if you look at this equation carefully, you'll notice that it is not balanced. It's not really balanced yet. So in order to balance this equation, I need to place some coefficients. On the left-hand side, I have 2 aluminum atoms, or sorry, I should say ions. They're still in ionic form. On the right-hand side, I need to have 2 aluminum ions. So to get there, I need to put a 2 in front of the aluminum ions. You'll see also that I have 3 sulfates. I have 3 of these SO4 groups. So I need to also have 3 on the right-hand side. All right, so now that I've written this dissociation equation, I can now tackle this problem a little bit better. So I'm told I have a 0.40 mole per liter solution of aluminum sulfate. But here's what happens with aluminum sulfate. Okay, when aluminum sulfate dissolves in water and it's forming a solution, it actually releases 2 aluminum ions and 3 sulfate ions for every mole of aluminum sulfate. When we talk about aluminum sulfate as one entity, we say it's got 1 mole. If I have 1 mole of aluminum sulfate, when that's broken up and released into its dissociated ions, the product is 2 aluminum ions and 3 sulfate ions. Because we need to remember when we dissolve something, I'm going to draw a little picture here. This is not what it looks like in reality, but I find this is kind of a helpful visual. When I picture aluminum sulfate as a compound, it's technically we're going to think about it as one entity. But when it's in water and its ions are able to dissociate because they form bonds with water molecules, and the water molecules surround them, the crystal lattice disrupts. What we get out of this are separate entities. So I get a separate aluminum ion. I get 2 aluminum ions separated from each other. And this means that we consider them to be different, separate entities. Over here, we consider this to be one whole thing. So we would refer to this as maybe one whole entity or maybe 1 mole of aluminum sulfate. But when it dissociates, it turns into 2 moles of aluminum ions, and we make 3 moles of sulfate ions. So as soon as we have separate entities that are no longer part of a compound, we have to consider them separately from the whole, from the group. Okay? This is a little bit like thinking of yourself as one person. You're one individual, but you're made up of different components. And if for some reason, like the Wicked Witch of the West, somebody threw water on you and you were able to dissolve into your separate parts, you would notice that one of you would turn into two eyeballs or two arms. Okay, that might be a little bit gory, but you're all grown-ups. So we get two eyeballs or two arms, and I can't think of anything that we have three of at the moment, but that's kind of the analogy. We break up into our separate components, and that's what's happening here. We have a molecule of aluminum sulfate turning into 2 aluminum ions and 3 sulfate ions. So when I go ahead and calculate the concentration here, I'm really just going to use the coefficients here from this equation. Okay, so what is my concentration? And here I'm going to use a different way of writing concentration. We can also write concentration as like square brackets with the thing that we're talking about in the middle. So the concentration of aluminum ions is 0.40 moles per liter. And here I'm going to do some more unit analysis. I'll just move my page over. 0.40 moles per liter times, well, I have 2 aluminum ions per 1 aluminum sulfate, like that. So really, my concentration of aluminum ions is just going to be 0.40 times 2. I get twice the amount of aluminum ions out of this solution. And that's because I have 2 aluminums per compound of aluminum sulfate. All right, let's do the same thing for the sulfate. What is my concentration of sulfate ions? They are 0.40 moles per liter times, I get 3 sulfate ions per 1 aluminum sulfate. Oh, sorry about that. Move my page over. So my concentration of sulfate ions is actually 1.2 moles per liter. 3 times that amount. All right, let's go over to example 4. This is our last example. This is asking for a mass of sodium carbonate. What mass of sodium carbonate? So when we talk about mass in chemistry, we're trying to figure out grams. Grams. What mass of sodium carbonate is needed to make 0.400 liters of a 0.0500 mole per liter solution of sodium carbonate? So we should probably start out by figuring out what sodium carbonate is. What is its chemical formula? So what is its chemical formula? You should be able to do this at this point, so I'm not going to spend some time going over how to find the formula for sodium carbonate. Hopefully you have your data booklet with you, but sodium carbonate looks like that. There's sodium carbonate. And we need to make a 0.0500 molar solution of sodium carbonate. So the first thing I should probably figure out here is how many moles of sodium carbonate I have. Because what I have a volume and I have a concentration. And I know with volume and concentration, I can multiply them together to get number of moles. Once I have my number of moles, I can take the number of moles and figure out my mass in grams. I can do this by taking my number of moles, N, and multiplying it by the molar mass. This is the strategy I'm going to use to solve this problem. So let's go ahead and do that. So my number of moles are, here I might actually write it a little bit differently. I'm going to write it kind of all stretched out here. I'm going to expand it and like stretch it out. Volume times concentration. So I have 0.400 liters times 0.0500 moles per liter. So that's V times C. And all together, V times C gives me N. The only thing I have to tack on here at the end is the molar mass of sodium carbonate. Okay, so I'm just going to pause the video here and I'm going to calculate that. So the molar mass of sodium carbonate is 105.99 grams per 1 mole. And the way I've set this up now, I can actually cancel out a lot of my units. And the unit I'm left with should be the unit of my final answer. So liters can cancel out with liters. Moles can cancel out with moles. And all I really have to do to solve for mass is put all these numbers together. Okay, so let's go ahead and calculate that. So I have 0.400 times 0.0500 times 105.99. And what do we get here? I get 2 how many significant digits? I should have 3 sig digs, it looks like. So this gives me an answer of 2.12 grams. And there you go. That's it. See you in the next video. I'll probably do one on dilutions.